So hello everyone. Today we are going to see the remaining commands of drafting. To start with, I am going to start with this surface finish. So to start with surface finish, first we need to select the surface or feature on which we have to apply the surface finish. So I am going to select this edge and then we are going to go for surface finish option. Here in this option you can see there are three basic symbols given. First one, it is showing basic, second is machining required, and third one is machining prohibited. So to understand this, I have one image. We are going to refer that image here. Now you can see in basic, surface may be produced by any method. Means here you can either use machining method, that is using of machines in which we are going to use grinding machine, milling machines, super finishing machines, super grinding machines, etc. Or else we can use the method in which the material removal will not occur. That category contains finishing processes like casting, forging, hot finishing, cold finishing, die casting, powder metallurgy, or injection molding. So either ways you can go. You can use surface finish method by removal of material, or else you can use the material removal method in which machining is prohibited or not needed. Either ways you can go if this symbol is being shown. But suppose if the symbol is shown with the line or a bar, then it is compulsory to use the method in which material is going to be removed. Such as you can see here, it is written that material removal by machining is required. The machining methods may be grinding, milling, honing, buffing, super finish grinding, etc. But in which compulsory material is going to be removed. The other method it is showing here with circle symbol. It means that material removal is prohibited. The circle in the V indicates that the surface must be produced by processes such as casting, forging, hot finishing, cold finishing, die casting, powder metallurgy or injection molding without subsequent removal of material. Means in this case material is not going to be removed, still the surface finish is going to be obtained. So these are the three basic symbols, that is this A symbol, the B symbol and the D symbol. Now we are going to again move to SolidWorks, and that symbols are being shown here. All the three symbols are being shown here. So now we will understand the layout of that symbol. First I will select the method, that is machining is required, and then you can see these two boxes at upper left side. These two boxes are representing the maximum roughness and minimum roughness required. The lower left side box is used for machining allowance. The box coming at the upper side of the line is shown for the production method or treatment, and here we are going to show the lay direction. In this box we are going to show sampling length, that how much length is to be surface finished. So to start with the surface layout, I am going to apply the maximum roughness and minimum roughness. The maximum roughness I am going to add here is, that is 70 microns. The minimum roughness I am going to add here is 0.03, that is 30 microns. And the allowance here I have kept here is 100 microns. So I will show it 0.1. Here the box above the line will show the treatment. So I am going to add the production method here. I will say it milling process. Here I am going to show the length. Here I am going to show the length of the machining cut. I'll say it 40. As this radius of the cylinder is 20, that's why I am taking here the length as 40, sampling length. And next I am going to show the lay direction. It is also called as the pattern which the tool is going to make according to the surface finish operation on the surface of the part. It may be multi-directional, means the material removal will be multi-directional, or else it can be parallel, or else it can be perpendicular. So according to the production treatment, this lay direction will be decided here. I'll select multi-directional, and now you can see this complete layout has been shown on the surface which we have taken for machining. I'll say it OK. Now if you want to change the text size, you can go here, put off this use document font option, go in font. I'll say it 10, say it OK. Now this text is coming a little bit smaller here. If you want to orient this, you just need to select it, or you can orient it by the direction also. So for orientation of this symbol, angle option is also given and directions are also being shown. So in both ways we can change the orientation here. So this was surface finish option here. The next command we are going to see here is weld symbol. So to start with, I have one image. We are going to refer that image. Now these are the basic types of weld. Other than this, there are multiple types of weld which come under these 5 categories. So we will just see the spy categories first. First one is butt weld. When two plates or two parts are being placed aside and they are joined together, that time we need to give butt joint. If two plates are kept lapped over each other, at that time the corners between the two plates can be welded by using this lap joint. The next joint is corner joint. In this case also you can see one horizontal plate is kept and one vertical plate is kept, and some clearance has been provided here to provide the weld required. So in corners you can provide the corner joint here. Next, here the orientation is just flipped here and the structure is kept in T section. That is one horizontal plate and one vertical plate, same like corner joint but flipped. This time this T joint has been provided by providing two welds on the corners on both sides. The other one is edge joint. When two plates are kept vertically with each other and they are needed to be joined from the upper or lower side at any one side, that time edge joints are placed. These plates are kept parallel to each other. These were the five types which are basic for the joints in weldments. Now we are going to see now we are going to see how this layout is being placed on the joints. So for that we are having this image here. Now you can see in this T joint, one is vertical plate, one is horizontal plate, and in between these two plates, one weld is being shown. Now the size of the weld is being shown. The horizontal it is 3 by 8 and vertical it is 1 by 4. This arrow is placed at the weld side, and when the arrow is placed at the weld side, the values and symbols are to be shown at the lower side of this line, this horizontal line. That's why the sizes are being shown at the lower side here, the horizontal line, and you can see the symbol is also been added, that is fillet weld. Now this weld is on the other side and the leg lengths are equal. Now this weld is on the other side. You can see here where the arrow is been placed, the weld is coming on the opposite side, not on that side. That's why when you show this symbol here, that time you need to place these values and all at the upper side of the horizontal line. Now it is saying that the weld is on the other side and the leg lengths are equal to 3 by 8 with the length is 7. So now the weld size is being shown, that is 3 by 8 on the both sides, as well as the weld length is also being shown, that is 7 mm. You can see here. The third scenario it is the weld is on the arrow side, equal leg length is 3 by 8 and intermittent weld length is 3 and pitch is 5. Now you can see here this arrow is placed at the weld side only, but the welding here is intermittent welding. That's why it is saying that the weld length is 3 mm. You can see here this weld length is 3 mm, and this pitch means center to center distance of one weld to another is 5 mm, and the cross sectional size of this weld is 3 by 8 by 3 by 8 horizontally and vertically. Next, the weld is on both the sides of the leg and the lengths are equal. So now here you can place this symbol at any side as both sides are been welded, and you can see here the size of the weld is been given, that is 3 by 8 by 3 by 8. So at the left side of the weld symbol, the value of the size is been placed. Now here these plates are kept lapping at over each other, and here it is shown the arrow. The arrow is on the welded side. That's why this weld is coming on the arrow side only, and the size of the weld is 3 by 8. So these are the techniques by which we can place the layout here. This is the layout, and now we are going to shift on SolidWorks. Now I want to weld this plate, yellow plate on this green plate at this side. So I'll select the common edge first and then go for the weld symbol, or select the side or the placement where you have to put the weld and then go for the symbol. Next I'm going to put on the arrow side, that's why I'm going to put the values at the lower side of this horizontal line. I'll select this and say fillet weld, put up the size of the weld here. If you want to keep the weld at certain length only, then you have to put the value here, or else if the weld is continuous, you don't need to put the weld length there. Then one symbol is also given here, that is peripheral. If I put this symbol on, you can see one circle is being shown around the arrow. Now when this circle is being shown, it proves that weld is to be provided on all the sides of the part, means all around symbol. And now if this symbol, that is field or side symbol, one flag has been appearing, it symbolizes that the weld is not to be provided at the manufacturing side, but is to be provided at the assembly side, means where the machine is to be mounted or assembly is to be done. Next you can see one counter symbol is also given. This counter symbol represents the finish of the weld After providing the weld, you need to finish that weld as the surface is very rough. So you can make flat weld. You can also go for convex or concave shape. So I'll provide here flat symbol. And now this is the tail area where you can provide the message for the manufacturer if any. Suppose I need to say that this welding is been provided by gas welding. So I'll write here as gas welding. Now one note is also been provided in this tail. So this area is tail note. And this area is for the same side of the arrow where we are going to place the arrow. The weld will be provided at that side only. And if I provide the symbol on the upper side, the weld will be provided on the opposite side of the arrow. So if you want, you can add the symbol here also. I'll provide the same values here. Suppose if I want any length also, I can provide the length, the finish, and say OK. Now you can see this symbol here. This is the weld value, that is weld radius. This triangular symbol is representing the type of weld. This line is representing the flatness or counter finish you required after the weld. And this is the value of the length. This flag is presenting that the weld is to be provided not on the machine floor but on the floor where the assembly is going to be mounted. This is the message in a tail note if you want to provide any message. Both the sides means this weld is to be done on the same side of the arrow which represent the lower side, and the other side of the part also which is been represented by the upper side. So this is the weld symbol, and this way you can provide the weld here. Say OK and finish. Now the next command we are going to see here is datum feature. Datum features are applied before applying the geometrical tolerances. Datum features are nothing but the references which can be referred so as to put up the tolerances for GD&T. So to start with datum feature, I'll select this option here to represent the three standard planes and constrain the movement of that particular part in three directions. So here are the three basic datums we are going to provide. So the base of this part, I will select it as datum A. As you select the command, you just need to click on the edge where you want to apply the basic datum, the primary datum. So the base face is the primary datum. Second, I'll take this face as it is perpendicular to the datum A. Now you have to keep in mind all the basic three datums will be perpendicular to each other. Compulsory they are going to be perpendicular. So I've taken this bottom face as datum A, side face as datum B, and now we are going to take this front face as a datum C. So I cannot put up this front face datum C in this view. So I'm going to refer this view for datum C. So I'll put up the datum here also. Just need and select the datum. Now how to utilize these datums? We are going to see geometrical tolerances here first. So these were the datum features. Now we are going to see datum targets. So to understand datum targets, I'll refer this image here. You can see one image has been shown here. Now one part is kept on a fixture plate and the supports are provided so as to make that part constrain in all three directions. So now whatever these instruments are that are being touching on this part are creating a particular datum target here. You can see this circular part is being touched to this circular rod, vertical rod, and it is being touched by the line reference. So here the datum target is line. Here also you can see this part is kept on this face and there is one pin mounted on this part. You can see here this pin is being shown. So here is the detail view of that particular pin. So this point of that pin that is touching the surface of the part is nothing but datum target of that particular point. So the datum target can be a point or a line. One more type of datum target you can see here, that is datum target of area. Now this part is rested on these two pins having the flat face area above. So where the part is rested, it is shown in detail view here. You can see this blue face here, that is flat surface area. So that is datum target area. So datum targets are nothing but some of the special points in a fixture that are used to constrain the part or make the part stable on a fixture. So these are the datum targets. So here we can see datum target option has been given. So I'll select here as this datum target. So now in this part I am considering this dowel hole as a datum target. Whatever the features placed here, that is the cylindrical shape or the cutouts that are being referred for the position from this dowel hole only. So now this dowel hole becomes the datum target as it will refer all the positions of the other features that are to be placed on the part. So I'll select this hole as a datum target For that I'll select this option, and you just need to put this icon symbol here and just place this icon outside the part area. Say OK. Now when you click on this datum target, you just need to double click, and here you need to provide the reference for that datum. That is one initial that is to be provided in capital letters. So I have provided here datum as A. So now this datum target is named as A. Here you need to provide the additional information if you want. So we will just check the diameter of this hole. Now this hole is showing as diameter 12. So here I'll double click on this icon and then put up the value here, say 12. It will automatically take the diameter symbol here and say OK. So the dowel hole I have considered here as a datum target for the part. Datum targets are usually placed so as to constrain the parts in a fixture. These were datum features and datum targets. So for applying GD&T commands, we are going to continue in next lecture. Till then, thank you.